This is a presentation on section 12.4, quick mole ratio review, and a new topic of percent yield. Let's take a quick review of what the mole ratio is. It can be expressed as a conversion factor that relates moles of one substance to the moles of another in a balanced chemical reaction. So moles of one over moles of another. So here's our balanced chemical equation. If we're looking for the mole ratio, mole ratio of aluminum to aluminum oxide. See, that's going to be 4 to 2, but it needs to be expressed in a conversion factor. So when you do our stoichiometry, it makes some sense. So the mole ratio is 4 moles of aluminum to 2 moles of aluminum oxide. And again, those come directly from the balanced chemical equation. That's where we use our coefficients. No need to simplify. In fact, you don't want to simplify. You want to keep these exactly the way that they are. So that when you go back to check your work, you can see where those numbers came from. So let's do a mole ratio problem. If you have 6 moles of aluminum, how many moles of aluminum oxide can be produced? Starting out with your balanced chemical equation. You always have to have that. Start out with 6 moles of aluminum. That's what you're given. So you start out with that. Do your conversion factor, and you will end up with moles of aluminum oxide at the end. So this is your mole ratio, going from one unit to another, going from moles of aluminum to moles of aluminum oxide. And when we do this, it has to be in moles. It can't be in grams. So we start out with the denominator, moles of aluminum. Put that in the denominator, so you'll cancel it. Put moles of aluminum oxide in the numerator, and then follow up with your numbers from your balanced chemical equation. When you do your calculations, you'll cancel out your moles of aluminum and end up with moles of aluminum oxide at 3.0. So that was just a quick review of the mole ratio. Let's take a look at the new section here. So how good are you? A little analogy with basketball. If you sit at the free throw line, you make 12 attempts and you make 9 of them. The question is, how good are you? Your percent made will be the number made over the attempts. So it's going to be 9 divided by 12. If you're looking for a percentage, you need to multiply that by 100 to give you a percentage, and you're at 75%. The exact same thing holds for chemistry. That's what we're going to be talking about, a yield. So 2 types of yield. First one is theoretical yield. That is the maximum amount of product that can be produced by a chemical reaction. You will do this by stoichiometry. This is what we have been doing, figuring out how much you can produce of these products or how much you need for a certain reaction and so forth. The second yield is the actual yield. That is the amount of product that is actually obtained during an experiment. Could be called a number of different things or phrased a number of different ways. A chemist made, a chemist produced, a manufacturing process, yielded, a whole bunch of different things. But that's what was actually done, getting into the experiment, what was done. I will always have to give you this number. I will always have to give you the actual yield. You can't calculate it. It has to be given to you unless you're in the lab, and then this is the number that you will obtain. You're going to do an experiment, and this is the actual number that you obtain in the end. Excuse me. So the percent yield is the ratio of the actual yield over theoretical yield, just like in basketball. Actually made over the attempts is the basketball analogy. Here we have the actual yield over the theoretical yield. How much is it possible for you to make? And again, times 100, the exact same thing. So the actual, again, is from the experiment. Theoretical, uses stoichiometry. Let's do a practice problem. Here we have our balanced chemical equation. Again, can't stress this enough. You need a balanced chemical equation to do these. If you start out with 14.0 grams of aluminum hydroxide and you have excess HCl, that means you have more than you actually need. You have a whole bunch more. You don't have to worry about that. Your aluminum hydroxide will be your limiting reactant. That's going to be your limiting reactant. The other one's going to be your excess reactant. So you don't have to worry about that HCl because you have more than enough. If I were to tell you that the actual yield is 22.0 grams of aluminum chloride, the question then is, what is the percent yield? As always, you start it with what you're given, 14.0 grams of aluminum hydroxide. Grams of aluminum hydroxide in the denominator. You need to figure out moles of aluminum hydroxide. Looking at our periodic table, we know this is going to be 1 mole, doing our mole conversion, going from grams to moles. On the bottom here is the molar mass of aluminum hydroxide. I'm not going to show you how to do that. You should know how to do that by now, but the answer is 78.0 is the molar mass of aluminum hydroxide. Now, we're set to do the mole ratio. Moles of aluminum hydroxide in the denominator. Moles of our aluminum chloride in the numerator. Now what we need is our coefficients from the balanced chemical equation. Moles of aluminum hydroxide is 1. Moles of aluminum chloride is 1. In this case, they're both 1s. Do another dimensional analysis. Moles, AlCl3, and you're trying to figure out grams of AlCl3. That's what you're trying to figure out. Dimensional analysis problem, we need a 1 mole down there, and then we need the molar mass of aluminum chloride on top, 133.5 is that answer. So now we're set to go. If we cancel out our units, grams of aluminum hydroxide, moles and moles will cancel. Moles of aluminum chloride, moles of aluminum chloride. We will end up with grams of aluminum chloride for our answer. And how we will get that is take our 14 times 1 times 1 times 133.5 divided by 78.0 divided by 1 divided by 1. When we do that entire calculation, we get 24.0 grams of aluminum chloride. So that's going to be our theoretical yield. Theoretical. It's solved using stoichiometry. Our actual yield is always going to be given to us in a problem like this. So what we're looking for is our percent yield is equal to actual over theoretical times 100. Our actual yield, 22.0 grams AlCl3. Theoretical, which we just came up with, 24.0 grams AlCl3 times 100. 22.0 divided by 24.0 times 100, and we will get 91.7% for our answer. Couple of step process. Number 1 is to figure out your theoretical yield. Second one is to figure out your percent yield since you are given the actual yield, and you just solve for your theoretical yield. Do the calculations, and you come up with your answer. This concludes the presentation on percent yield and a quick review of the mole ratio. Enjoy the rest.